everyone, it's Justin again. So this unit is about quadratic functions. But did you realize that you've already spent a lot of time working with quadratics in this course? You spent a lot of time working with quadratic expressions, like these, which you were often asked to factor. But now we're going to start working with quadratic equations, like these, and solving them. How do you think that solving quadratic equations will be different from factoring quadratic expressions? Well, solving means you find the value or values of the variable that make an equation true. So unlike what you've seen before with just factoring, the answer to an equation should always be the value or values for the variable that make the equation true. So those answers would look like the variable equals something. But how do we figure out what that something is? In your warm-up on the cover sheet, you should have considered solutions to these three equations. If you haven't completed this warm-up yet, pause the video here and do so now. You probably solved these first two equations like this. But then, notice that in the third equation, there are two instances of x. We can't isolate x in this equation, so there has to be another way we can approach it. Let's look back at these first two equations in a different way to see what we come up with. The first equation says that a times 5 equals 0. What kinds of factors make a product of 0? Only 0 times something will make a product of 0. That means that a has to be 0, so that 5 times it equals 0. The second equation feels more complicated, but only because there's a grouping here. What if I think about this b minus 2 grouping as just one big factor? Then I have 3 being multiplied by something to get 0. What do I have to multiply times 3 to get 0? Yeah, this factor has to be 0, so that 3 times 0 will equal 0. If our factor b minus 2 must be equal to 0, then we can write an equation from that and solve it to get that b equals 2. Even though we didn't need to think about these equations in this way to be able to solve them, we did need a different way to consider this equation. Now that we've approached the first two problems together by thinking logically about factors that multiply to 0, pause and try this problem one more time independently using that same logic. There are two factors in this problem, and even though we don't know their exact value, they each have to be some number, right? So let's look at x minus 1. I know x minus 1 has to be some number, and even without knowing exactly what number it is, what can I multiply it by to ensure that it equals 0? 0. We know that anything times 0 will make 0. That means that this factor, x plus 4, would have to be 0. Solving tells me one solution to this equation is x equals negative 4. But it's not the only solution. What if we go back and reconsider? Imagine we don't know what number x plus 4 represents. No matter what, if it gets multiplied by a factor of 0, it will still make a product of 0. So another way to make this equation true is if this first factor, x minus 1, is 0 instead. That will happen if x is 1, giving us our second and final solution to this equation. To make this equation true, x could be 1 or negative 4. If we substitute each solution back into the original equation to double check them, we can see that this equation is able to have two solutions, because each of them guarantees that one of the factors is 0, which will always result in a product of 0. We can actually take this and generalize it into a property that is incredibly useful. Imagine that we have any factors being multiplied together to create a product of 0. We'll call them A and B. What can we tell about this equation based on the fact that it is a product of two factors that multiply together to make 0? The only way for two factors to multiply to a product of 0 is if one of the factors is 0. We can summarize this by saying if A times B equals 0, then either A equals 0 or B equals 0. This phenomenon is called the zero product property, and it's really useful for solving quadratic equations. With quadratic equations like this, we run into a similar problem. Since there is an x squared and an x, it's not possible to isolate x. But we can still solve for x, thanks to the zero product property. If we manipulate our equation to get the quadratic expression equal to 0, then we can factor it and be left with an equation made up of two factors multiplying together to create a product of 0. When two factors multiply together to create a product of 0, what does the zero product property tell us must be true? Either the first factor, x plus 2, must be equal to 0, or the second factor, x minus 5, has to be. Check that out. Even though it wasn't possible to isolate x in our original equation, the zero product property has helped us create two smaller equations where we can isolate x. What solutions do these give us for the original equation? X equals -2 or x equals 5. Notice that we ended up with two solutions, one for each factor in the factored form of the quadratic. An equation can actually have up to as many solutions as its degree. So whenever you're solving quadratic equations, keep in mind that you can have up to two solutions. It's important that you provide all of the solutions to an equation for your answer to be completely correct. Let's put the zero product property into action with two example problems. The first example problem says to solve 2d squared plus 19d plus 11 equals 5d minus 9 by factoring and using the zero product property. What do you think we should do first? Well, we can't use the zero product property unless our equation equals 0. But right now, it's equal to 5d minus 9. Luckily, you are a pro at manipulating equations, so pause the video here and get your equation equal to 0. Using inverse operations, I'll subtract 5d on both sides and then add 9 on both sides. Now my equation looks like 2d squared plus 14d plus 20 equals 0. What still needs to happen before the zero product property will apply here? We have the equals 0 part down now, but still no factors. How can we fix that? Of course, we can get factors by factoring the quadratic expression. Pause the video here to factor this and try solving using the zero product property. To factor this, I need to break up 14d into two d terms whose coefficients multiply to 2 times 20, or 40, and add to 14. Oh, that's 10 and 4. Now I could take my 4 terms and put them into the box from the area model of multiplication and create my factors so that they multiply to make the terms in the box. Remember, these factors are another way of writing just the quadratic expression, so I still need to bring down that equals 0. Now, what I have is two factors multiplying to make 0. The zero product property tells us that when this happens, it means one of the factors must be 0. So either 2d plus 10 is 0 or d plus 2 is 0. What solutions do these equations give? we get that d can be -5 or -2. Did you notice that my trinomial actually has a GCF that I could have factored out? Look way back up here. Each of these is divisible by 2. This is why I wound up with the factor 2d plus 10, which also has a GCF of 2. I could even factor that GCF out still. In fact, if I had noticed that at the beginning, I could have divided everything on both sides of my equation by 2. Remembering to look for GCFs can help make your numbers easier to work with, but ultimately, if you don't notice it, it won't cause your solutions to be incorrect. Let's do one more. The second example problem says to solve 4m squared minus 2m plus 7 equals -18m by factoring and using the zero product property. Pause the video here and try to do this problem entirely on your own first. Let's go through this. In order to solve an equation using the zero product property, I need a product of factors that equal 0. So first, I'll add 18m to both sides of this equation, making 4m squared plus 16m plus 7 equals 0. To factor the quadratic, we need to break up 16m into two terms whose coefficients multiply to a times c, which is 28, and add to b, which is 16. That would be 14 and 2. With 16m now split up, I can take my 4 terms, put them into the box, and find the missing factors that will multiply to create these terms. In this case, those factors are 2m plus 7 and 2m plus 1. If we rewrite our equation as 2m plus 7 times 2m plus 1 equals 0, check it out. We now have factors being multiplied to make 0, which means we can use the zero product property. If you got stuck up to this point, pause the video here to finish solving this. The zero product property tells us that since they multiply to make 0, then either 2m plus 7 must make 0 or 2m plus 1 must make 0. We can solve both equations to see that m is either -3.5 or -0.5. Factoring and using the zero product property is a great method for solving quadratic equations, but make sure you're thinking critically each step of the way. One of the most common mistakes that I see students make is rushing straight into factoring and separating the factors into two equations, each set equal to 0. But remember, to do that, we use the zero product property. So if you don't get your quadratic expression equal to 0 first before factoring, then you can't use the zero product property on the factors. After you finish up your guided notes, work on the additional practice in your PDF to check out some unique cases before you move on to the online practice. In addition to using the zero product property, you'll be doing a lot of factoring in the practice, which we originally learned together in our polynomials unit. You may even want to pull your factoring notes out now so they're on hand while you work. Good luck, and I'll see you next time.